For 3.7, we are going to do transformations on polynomial functions. And polynomial functions have similarities according to whether they are an even degree or an odd degree. You know that an x squared is a parabola. Well, it turns out that x to the fourth is a similar shape. It's not called a parabola. It doesn't have the same geometric properties as an x squared graph, but it's still U-shaped. So an x to the fourth graph is the same thing, only thinner. And an x to the sixth graph is the same thing, only thinner. Now, an x to the fourth can look like a W, but that only happens when you have x to the fourth and x to the third and x squared and x and a constant. Does that make sense? So everything that follows the x to the fourth can turn it into a W. And an x to the sixth can be a double W. So that double W is created by x to the x to the fifth term and the x to the fourth term and so on. Okay? But just a plain x to the sixth looks like a super skinny parabola. And we could do x to the eighth and x to the 10th and so on. The same sort of thing happens with the odd exponents. An x to the third is this shape. An x to the fifth is the same looking shape, only thinner. And actually thinner is incorrect. Technically it's taller. And then x to the seventh is the same basic shape, only much taller. Okay? And once again, an x to the third can actually hit the x-axis 3 times. But those other roots create an x squared term and an x term and a constant term. And an x to the fifth can actually hit 5 times. But it would have an x to the fourth term and a third and a squared and a first and a constant. Does that make sense? Okay. So if I wanted to graph y equals x minus 3 to the fourth plus 1, all I have to do is take the parent function x to the fourth and move it. X to the fourth is a very tall looking parabola. And then what does x minus 3 do? It's going to slide it right 3, and the plus 1 moves it up 1. Okay? What would y equals x plus 2 to the 7th minus 5 do? Well, it's a very tall x to the third graph. And we're going to move left 1, 2, and down 1, 2, 3, 4, 5. Does that make sense? Okay, that takes us through the first set. All right. What if I had an x to the fifth graph? Well, yeah, we'll say x to the fifth. Let's say I had this graph. Okay. And let's call that graph f of x. And I wanted to graph to f of x minus 1 plus 3. So we need to take the original equation and we need to make it twice as tall. Let's see if it will let me do that. Yeah, there we go. So that graph, and not quite tall enough yet. So that graph is twice as tall. Agreed? Okay, now what? So we need to go right 1 and up 3. And you can do that with any function. If you have an original graph, and we know that this is probably an x to the 5th graph. It could be an x to the 7th or 9th or 11th. Can it be an x to the 3rd? How do you know the red graph is not an x to the 3rd? It hits 5 times. So it's at least a 5. How do I know it's not a 6? A 6 would start and end in the same direction. So it has to be odd because the left side is down and the right side is up. And it hits 5 times, which means it's x to the 5th or larger. It could be a 7 or a 9 or an 11. So to make it 2 times taller, you just look at specific heights and you double them. So this height would be doubled to there. And that's kind of what I tried to create. So you see how, you see how this height is doubled to there. And this height is doubled to there. And really, just make it skinnier and taller. I mean, I'm not terribly, we're not terribly concerned about if your graph is perfect or not. And you'll have to write the description. I mean, in some of these problems, you'll say twice as tall, right 1 and up 3. Okay. All right. This gets a little bit trickier. What if I said f of x is x minus 1 to the 3rd minus 3, and g of x is 2x minus 4 to the 3rd minus 4. What do we need to do to f of x to create g of x? Twice as tall, so we went from a 1 to a 2, so g of x is 2 times taller. And this graph originally is right 1 and down 3. But the new graph is right 4 and down 4. Do you see that? So I need to go an additional 1, 2, 3 to the right, and an additional down 1. And that's kind of tricky because this graph is right 4, down 4 of the original x to the 3rd graph. But that's not where we started. We started here. So we only need to go right 3 and down 1. Okay? So let's say g of x is 4x plus 1 to the 4th minus 3. And h of x will make it 2 times x minus 5 to the 4th and minus 5. So what do we need to do to g of x to turn it into h of x? 2 times shorter, or half as tall. Right? The g of x is 4 times the parent function, and h of x is 2 times, so we need to cut it in half vertically. All right? And then right 6. The original graph is left 1. The h of x is right 5. So to go from negative 1 to positive 5, we need to go right 6 and down 2. Does everybody understand how to do those? All right. That might actually take care of us. So we want to do 3.7. We'll do 1 through 21. So 1 through 21 odd, and then I'm going to throw in 25, just 25. And 25 is a little bit tricky. What if I had x squared minus 6x plus 2? How could I go right 2 and up 3? Well, I have to turn every x into x minus 2. So it ends up being x minus 2 squared minus 6 times x minus 2, and then plus 2 plus 3, which is plus 5. Yeah, 20. That's basically what you're going to do for 25. Let me see if they want you to multiply that out. Example 4. Oh no, hang on, you don't want to do 25. We're not going to do reflections. 24. That's the one we want to do. Yep, not 25. Do 24. That one doesn't have a reflection. And my guess is they will want you to multiply this together and simplify. So you'll get x squared minus 4x plus 4 minus 6x plus 12 plus 5, and then you simplify everything. Okay? What if, and I better do this because they're going to do it in yours, what if I wanted to make this 3 times taller, left 1, and down 4? So 3 times everything, x plus 1 squared minus 6 times x plus 1 plus 2 and a minus 4 on the outside. That takes it down 4. So why did I not just put the minus 4 on the inside? Right, then that 3 would actually make it down 12 instead of down 4. So remember, this would be 3 times f of x plus 1 minus 4. So that 2 is part of the original f, and you have to triple it before you go down 4. And you'll have to do that on number 4. Okay? Or 24. Right.